Hello there, I'm Thomas, the pilot flying the Airbus A340-300 in this flight from Zurich International back to Zurich International Airport. We're going to be flying at flight level 250 to 35,000 feet with Mach 0.82 or 340 knots. And right now I'm in the cockpit doing the pre-takeoff preparation. I'm going to be explaining some of the aircraft, the Airbus A340 313X systems, and do an engine start demonstration and some of the Airbus A340 systems demonstration and explanation. So right now you can see I'm in the cockpit, I'm in the cabin side. I'm using this Lszh Extreme 3D side stick fly the aircraft. So this is very close to the Airbus aircraft, so as close as I can get in a simulator. So you can see as I move left and right, the side stick of the aircraft also moves. If I move trying to pitch up or pitch down the aircraft, so it's doing the aircraft's side stick, both sides of it. So this is used to control the flight control surfaces of the ailerons and the spoilers for bang roll the aircraft left or right, and for pitching up and down the aircraft using the horizontal stabilizer elevator, which is right here, while the ailerons and the spoilers are right here in the wings, as you can see. So this is the primary flight display. You can see the airspeed displayed here, the selected or the managed airspeed over here displayed with blue or purple, and the selected is with blue, and here is the selected or managed altitude, which is selected here in the autopilot flight control unit, autopilot, auto thrust and flight director system panel. So this is the airspeed display here, 100 knots is also 100 knots here, but we're gonna change this for takeoff. The heading of 0 or 360 degrees is also displayed here. We can change this to the runway heading actually, or we can leave this managed for the system. So if I'm gonna change the heading to the runway heading of 135 degrees, I believe. So I'm gonna change the altitude in a while. I'm gonna select a higher altitude later. So you can see the heading here, which is selected with blue. We're gonna use this for takeoff and landing using the Lszh system. So it's also displayed here in the navigation display. Navigation display displays information from the GPS and other systems like can be explained later from their data inertial reference system. It displays magnetic or true heading, GPS position and gyroscopic acceleration, which makes a hybrid display over here. It's also fit to the flight management computer, which manages the aircraft in flight from takeoff to landing and completing a complete flight plan. Here you can see the CDU. So I'm gonna start the engines now. I'm gonna show you some of the overhead panel. We have the add the ice here selected on because it's quite cold. So here we also have the thrust levers display. If I move the thrust levers using the side stick, The thrust levers have addendums. They have climb, maximum continuous thrust, and takeoff go around. And below the climb is the manual selection of thrust. It goes all the way from the 32 to about 75%. So, if I said in the climb, it goes like 71 maybe. You can see here the selected value of the thrust lever ankle, which is displayed with a blue circle. If I move the thrust lever, the green needle also goes up to a new value. Goes all the way to the 86% right now, which is VN1. It's the low speed rotor, low pressure compressor stage of the turbofan engine. The exhaust gas temperature is 840 degrees per engine, and N2, which is the high pressure compressor high speed rotor stage of the turbofan engine, is 94.7% per engine, and the fuel flow is 11,480 pounds per engine per hour. We have a fuel on board of 71,800 liters. Engine flex temperature now. We have flex actually right now. Maybe that's why MCT. Yeah. Flex MCT and takeoff go around. So I'm gonna use back to the eyes. So if I move these levers here up, I'm gonna use the thrust reversers. You can see the thrust reversers being deployed here, which is used on landing for slowing down the aircraft. So here also we have the trim, the horizontal stabilizer of the tail, which is trimmed up or down depending of the aircraft's configuration, flight, and center of gravity, and other factors like the airspeed, like the pitch angle or the bank angle, and it's used to balance the aircraft in flight as much as is possible. And it's also it has both two modes. One is manual, which is set by the pilot by using this trim wheel, and the other is automatic, which is auto trim system, which is connected to the fly-by-wire system of the aircraft. So I'm gonna make a little bit faster now. Maybe I'm gonna come here for engine start. You can see the overhead panel. We have the air system here. We need the APU here. I'm gonna turn the APU master on and the start on. So if I come here in the lower ECAM, electronic centralized aircraft monitoring display, you can see the APU is starting. We have N1 and exhaust gas temperature, which is a smaller turbine, the APU, which supplies pressurized air and electricity, alternate current electricity in the aircraft during the pre-takeoff preparation mostly. You can see the bleed here, the bleed air. We need for starting the engine starters. I'm gonna make an engine start demonstration. So I'm gonna come in this view maybe. It's also a nice view of the aircraft. Jump seat, as you can see. You can see this view of the aircraft system. So here's the overhead panel. I was telling you this is the pressurized air from its engine. If I'm gonna turn the system off, maybe I'm gonna show you the ECAM here, the ECAM display. So if I'm gonna turn the engine bleeds off, I'm gonna use the electric. Oh, here we have it. We have all the systems actually. Oh, here is the bleeder. So right now I have turned off the left side engines bleeder. I'm gonna turn off on the right side engine bleeder. You're gonna see the message displayed here. I'm gonna connect them back. You're gonna see the engines are connected back. So this is a good simulation of the aircraft system. If I connect the APU, you can see the APU is connected here in the display. So if I'm gonna turn off the engines, if we have no engines power, it's gonna be only the APU to supply the engines for engine start. So this also is the cabin pressurization, which has two controllers, one automatic, one alternate automatic, and one manual, which pressurizes the aircraft cabin during flight. I'm gonna explain later about that. Here's the electric alternate current. We have generator 1, generator 2, which is actually generator 1 from the left wing engines, engine 1 and engine 2, and generator 2 is from the right wing engine, engine 3 and engine 4. We have the external B and external A in the APU, and the transformer rectifier, which transforms the alternate current into direct current for feeding the direct current buses and the battery buses. Some systems, mostly computerized, need direct current for supply. And this we have generator 1 from its generator 2 and generator 3 and generator 4, which is supplying 115 volts, 399 hertz, it's 48% load right now. The APU generator, the auxiliary power unit, supplies 116 volt, 400 hertz, and so here we have the direct current from battery 1, battery 1, battery 2 over here. Here you can see the generator 1, generator 2, and this also can convert the direct current to alternate current using a static inverter. I'm gonna be talking to you about later. So if I'm gonna turn off the generators, you can see the display here. Generator 1 is off and generator 2 is off because I turned off this button. So if I'm gonna connect generator 2 is back on. Here is supplied from the APU generator. So if I disconnect generator 2, the APU supplies both contactors, alternate current 1 and alternate current 2 buses contactor. If I connect generator 1, it's not needed for the APU to supply this generator, and it's automatically converted only to the generator 2. So I'm gonna use back the generators the way they are. I'm gonna show you the batteries. If I disconnect the batteries, there is nothing happening actually to the aircraft because it's supplied from the generators in the APU. So this is a different kind of configuration where we are in engine start. So here is the fuel panel. We have the wing, its wing tank has about 31,690 and 1,950 pounds in its wing, and the inner tank and the outer tank. And here you can see the fuel pumps in its wing, which supplies its engine 1, engine 2, engine 3, and engine 4, and we have the low and the high pressure valves, which are they are open right now. And here we have also the sender section tank, which is empty right now. We have fuel used 3,490 pounds and fuel on board 70,500. So if I turn off these pumps, you can see the yellow messages here, which is the primary pumps. I can also connect the X-feed to supply its engine from its from any tank and any pump through one line. We have all the X-feed now on, as you can see. can turn them on and off whenever I like. So we're gonna connect the primary pumps again, and we have the standby for its time. And here we have the hydraulics I'm gonna talk to you about later. The flight controls here, which they are connected with the electrical and the hydraulics, and the air system also. And here we have the hydraulics. We have an electrical and engine generator from its engine. Left and right outer engine is the green system, engine 1 and engine 4. Blue system is engine 2 and yellow system is engine 3 for this aircraft, the Airbus A340. You can see this green, blue, yellow and green again. And supplies mostly the flight controls with hydraulic fluid, which is pressurized by the air system over here from the engines. So if I'm gonna turn off one of these, you're gonna see the pressure is going down. The electrical is off right now, but there is still pressure from the engines. If I'm gonna turn off the engines, you're gonna see the pressure go off gradually. You can turn the electrical also on. So here we have the flight controls I was telling you. I'm gonna talk to you about later. So right now I'm gonna turn off these switches, the engine master switches. We have the APU on and ready, and I can turn off the master switches from the engines. Turn off the engines and then I make the engine start demonstration for this aircraft. So you can see another view here. You can see the engine going out. So right now, they're also displayed over here. The engines are off right now. So I'm gonna add the block fuel now. We need the APU bleed is on, so it's supplying the system. We need to turn the packs off, packs 1 off and pack 2 off, and turn this to the close to start the other side engine actually. We're gonna start the left side engines first. So the electrical is okay, the hydraulics and the fuel are okay. So I'm gonna come here and initialize this from, so we need next page, 0 fuel weight center of gravity. So we have 0 fuel weight 318, I believe, 1,000 pounds, 318,000 pounds. We have 74,000 pounds fuel. Here we have the block fuel 74, 7160. Why so low? Well, 70.1, 70.16. This is our block fuel, 70,000 pounds. So takeoff weight 387.8 thousand pounds right now. This is gonna change a little bit with engine starting, so I'm gonna use the engine start selector maybe. Need some dome light. Yeah. I'm gonna select here. This is the engine mode selector over here. we're gonna use the ignition start position. So this is going to initialize some systems. It's gonna open the engine start valve of the engine to pressurize the engine. So I'm gonna turn the engine 1 and engine 2 engine master switches, which is gonna start the pressurization. The engine and the fuel flow valves, they're gonna turn on when the N2 is gonna reach about 20%, 24%. Here we have it. You can see the engine start here. The right wing engines are still off, engine 3 and engine 4. So I'm gonna come over here and turn the switch in the other side in the auto position. I can use it in the open, but we need the auto for takeoff. So I'm gonna come and start the right wing engines, engine 3 and engine 4. And here we have it. You can see the spinner is increasing its rotation. It's spinning. And here we have the engine start for the right wing engines. You can see the PSI here and the valves go on. The N2 is okay. So here we have it. We can start the flight plan. This is all we need right now. Initialize. Back to Lszh. Align the RS and cruise flight 250, 35,000 feet, cost index, we need 100. Here we have the flight plan being created right now. Oh, we need the departure. I'm gonna use the runway 14, 012. And then the arrival, I'm gonna use runway 14. Transnegria 1 alpha, insert. And here we have the whole flight plan ready, displayed in the navigation display. Here we have the primary flight display in the flight mode annunciator. They're all set and ready. So I'm gonna use a little bit more altitude here. And some airspeed. For takeoff, I'm gonna use the flap position in flap number 2. We need the packs in the auto position. We're almost ready to go. So I'm gonna use the ILS on. We're gonna have the ILS displayed here in the primary flight display. It's going to align the aircraft with the runway heading. So you only need to set up the parameters of the takeoff. So performance. So here we have flap 2 and 2 up, the trim position. It's alike for takeoff. V1 maybe 145, 150, and 155 is good values. I want to use the manuals later on navigation here, but okay, here we have it. Maybe increase the range here. Maybe I can use some airports for display, as you can see. And we are ready to take off. We only need to set the trim over here, which is going to be displayed also from the flight controls. You can see the flight controls are fully movable. As I move out, this is the side stick. They're working. We have the ailerons and the spoilers, and the elevator and the rudder. So we're ready for takeoff, I think. So I'm gonna move on the thrust levers all the way up. Now the thrust levers in the takeoff go around and disconnect the parking brake. You can see the messages displayed here in the primary flight display, the flight mode on 0. We have 118 knots, 132, 140, have V1, V rotate, and V2. Here we take off. As you can see, we retract the landing gear here. You can see the modes here displayed in our airspeed. Our altitude is 500 feet above the ground, 600 feet is keep increasing. It's the radio altitude. 780, 800 feet. Our alignment with the runway heading. We can start turning now. Our barometric altitude above the sea level is 2,800 feet, and our altitude above the ground level is 1,500 feet above the ground. Our airspeed is 178 knots right now, increasing. We have manual takeoff go around in the auto thrust here arm. We have climb and altitude as our vertical navigation guidance from the flight management computer here. And we have the navigation for the horizontal. We have armed the navigation in the flight control unit in the autopilot. This is how we turn. The navigation displays some other airports being displayed over here. So I'm gonna start retracting maybe the flaps. You can still see our airport right here. So maybe we have like 40 more minutes for this flight. Maybe 30, I don't know. Have to check this out. So we have to move the thrust levers to the climb now. You can see if I move this up or down, it's changing the display over here of the mode. So I'm gonna leave in the MCT, which is maximum continuous thrust. It's gonna guide us very fast in the maximum altitude we have to fly for this flight. So we keep climbing past the 8,000 feet. You can see here the flight plan. We're gonna follow, maybe use a little bit more range to the 40 nautical miles. We don't need to climb so fast right now. This is the managed speed right now. So I'm gonna retract the flaps to increase the airspeed margin. You can see the stall speed here, the yellow tape over here. You can see our altitude and our vertical speed is 1,000 feet per minute right now. Our altitude is 11,180 feet above the sea level, and our rate of climb is 1,400 feet and increasing. And the airspeed managed is displayed with purple line. Here is 210 knots. But because we use MCT, we're gonna use maybe a higher airspeed setting. We're gonna pass this limit when we cross a higher altitude. You can see our Airbus A340-313X. It's a very nice aircraft, very cool. Very nice looking, like a Lincoln aircraft. We keep climbing, and I'm gonna be showing you some more views now. Have another aircraft over here. You need to be aware of other traffic. We have reached 17,500 feet. Our rate of climb is 1,100 feet per minute. So So now we have a selected airspeed over here and selected altitude we have to follow. The airspeed now is 325 knots selected. Our rate of climb is 2,900. We cross 19,400, 500, 600 feet. Our rate of climb is 3,200 feet per minute. And we have the auto thrust arm displayed in blue. We have an hard mode, the altitude, which is going to be engaged when we reach the altitude here, the 25,100. It's also displayed in blue here in the primary flight display. In the flight director 1 and 2, we cross 21,000 feet. We have the horizontal navigation here. which is the GPS navigation. We have many airports, so you also. If I increase the rates, you can see the Germany here. You can see parts maybe of France down here. 30, 40, 110. No, France is in the other way. We have to turn. West to show you France. Because right now we're going east, northeast. So still have no cool effect from the engine, I don't know why. So we have reached 25,000 feet. This is it, 25,000 feet. Gonna decrease the range a bit. We'll have better view over here. Need to start turning to the airport now. You can see how I try to hold level using the side stick only here. So we have to turn back to the airport, as you can see. We have lost the cool effects from the engine's exhaust, I don't know why. So we're gonna start turning back into the airport. We have no chemtrails tonight. We have to do it fast for landing. So I'm gonna try to hold level as I turn the aircraft. Sometimes some of the visuals are lost, I don't know why. So we cannot see some chemtrails, not alike. So we're gonna keep turning around. We have reached the maximum airspeed right now. So we decrease our thrust levers position and just turn back to the airport. Oh, here we have it. Now we have the chemtrail been displayed here. You can see it. Yeah, it's beautiful. Keep turning around towards the airport. Maybe we need a higher altitude, that's why we just have the chemtrails now. We reach 26,700 feet. You can see the chemtrail line here as I turn. You can see the four engines effect. I'm gonna start lowering down the aircraft a little bit. We have to go back into the airport, so we level off a little bit now. So we have like maybe 20 minutes to go, maybe less, maybe 10 minutes. So I'm gonna lower the aircraft down to the altitude that we need to be, and going back to the airport. Maybe use the direct to the last waypoint. Here we have it. We're just 1.1. We're very close actually to the airport. We're like 30 nautical miles away, maybe 40. So we're gonna keep descent. I'm gonna decrease the engine thrust and use some speed brakes for descent. And we have to set the autopilot again. So set the autopilot in a lower altitude mode. This is gonna be our approach altitude, our final terminal approach altitude fix. So you can see the airport here as we descend. I decrease the thrust levers. You can see the auto streaming the aircraft right now. This is trimming the tail of the aircraft. You can see it's increasing here: 4.1, 4.2, 4.3, 4.4, up. You can see the flight control, and stop. So stop rotating now. There's no more trimming. It's in a 4.4 position up here, as displayed over here. So we have a good thrust right now for this descent. I'm gonna decrease the range here. We have better view of the runway. Use a little bit more thrust right now. I use the glide tender, which arms the speed guidance over here to the 320 knots. For descent into the airport. So maybe we track the speed brake. Just leave the aircraft, go down with 320 knots for this approach. Okay. We're just 20 nautical miles away from the final fix, so we're gonna be like in 5 minutes over there. I hope so. Because maybe we have another 10 minutes for this video to end. So I have to get down and fast. into the airport. Here we have the river, as you can see. We are in a good position actually to land to see the river. It all depends in the airport. If we're gonna see the airport on time, then we're gonna be fine. We use the speed brakes to slow down. Oh, we are very close into the airport on the runway. As you can see. We have to come closer into the runway now. I'm gonna start turning. So have like 10 nautical miles range now. We are just 10 nautical miles away from the runway. If we make an angle here, a turn. So I think we should start turning right now. I'm gonna turn the localizer on. You can see the autopilot 1 and autopilot 1 with 2 and we didn't use, and the auto thrust here is on. I use the localizer and the ILS for the intercept landing. So we have the flight director 1 and flight director 2 on here, and the barometric altitude setting here to the 9.92 inches of hydrargus. So you can use also the hectopascal if we want. You have to slow it down a bit, I believe. Yeah, you can see the runway here, the airport. We are in a very good position actually for landing. You only need to turn into the river here, make a small turn correction, and as we keep descending, I'm gonna extend the speed brakes. I'm gonna extend the flaps now. And turn back into the airport heading, and also extend the landing gear. As you can see here, we have the landing gear been extended. Make a nice smooth turn here into the airport. We have our airspeed correct. Have to use a little bit more thrust for this turn, and our altitude here. And here we have the runways. This is our runway we're gonna land. Maybe use flaps 3. and just use a little bit more thrust. As we go into landing, retract the speed brakes. We need to align a little bit. You can see here we have the localizer and the glide slope. We have to align with the localizer. We're very close, and here we are. Gonna make a wild maneuver here. Five hundred, 400, 300, 200, 100, 50, 40, 30, 20, 5, and here we are. Reverse thrust and brakes and reverse thrust. We just landed. Very smooth landing, as you can see. We have the thrust reverses here. You can see the landing gear here is safe. We have no breakage in the wheels or the nose wheel. The landing gear and the tires and the struts are completely safe. You can see how nicely landed, how nicely lying. Still have a lot of runway to go. We have another aircraft here in the back. So I'm gonna come here. You can see the thrust lever reverses. Can turn them off. We don't need them. Turn them off. If I deploy them here, you can see. I like the noise they do. You can see the cockpit again. How to sound the thrust reverses. You can see our position here in the primary flight display. Our barometric altitude 1440 feet. We perfectly safe. The flight controls are okay. The engines are okay. And we have the tires here to show you. You can see the fuel tanks are okay and safe over here. The hydraulic systems, there is no leakage of hydraulic fuel. The engines are perfectly normal. And the wheels, you can see the temperature in each tire, and the wheels are down. There is no damage in the wheels as we landed, or the nose wheel. So a little bit more system. That was Thomas, the pilot flying the Airbus A340-313X for this flight from Zurich International and back to Zurich International. We just landed safely. It was nice to see you in this flight. So I'm gonna see you next time, maybe. I don't know when. Thank you for joining this video while flying the Airbus A340-313X. We did an engine start demonstration and systems explanation while in progress and flying. I'm gonna show you a little bit more systems. We have more time to record in this video, so maybe I'm gonna see you in another video. So here we still are. I think we still record, but I'm not sure. You can see another view here of the jump seat. See the back view, how it looks like. The overhead panel has night mode. You can see everything is normal. We have a data loader here. We have a lot of buttons actually. We have an ELT, we have a data inertial reference system. We have our flight control computers over here, ground proximity. Flight control computer. We have the primary and here the primary and the secondary flight control computers. Prim 1, second 1, the turbulence tumbler, and we have our calculation. We have also the engine manual start here and some ventilation and safety modes for other systems. You can see the engine fire, the hydraulics, the fuel pumps, the electrical, the air system panel, the anti-ice, the lighting, and the APU, the thrust levers, the radio management and navigation panel, which tunes the navigation aids here in the primary flight display, and it uses their data inertial reference system over here for GPS and acceleration, gyroscopic acceleration, and other data like magnetic or true heading, and also air data from the pitot static, which uses for barometric altitude and airspeed setting, and also pitot static, pitot dynamic, which uses moving air. And also we have the angle of attack, which uses the airflow of the aircraft as it flies to measure its angle of attack with respect to the air mass. So you can see all the systems are safe here. I'm gonna be seeing you in another flight with this side stick, as you can see, but I'm fine. So thank you very much for joining me. See you next time. Bye bye.